Welcome to this tutorial on the retest algorithm function in YieldOptiX. This function can be accessed from the YieldOptiX drop-down menu under Retest Algorithm, where the subfunction coordinate-based retest is available. The purpose of this function is to identify and differentiate between units tested for the first time and those that were retested, whether within the same log file or across separate test sessions. It is designed to track retested units for both wafer-level tests and package device tests. To demonstrate, a concatenated table containing thousands of devices will be used. YieldOptiX provides a comprehensive solution with multiple interactive options. To illustrate devices with multiple measurements, another function from the drop-down menu, Generate Basic Maps, can be used. As seen here, a template of wafer maps is generated. Without a column corresponding to test insertions, the default column configuration displays the unit count map per wafer in the dataset, which can be further modified. This visualization indicates that some devices appear multiple times at the same X and Y position. Now let's enable the coordinate-based retest algorithm. Once this function is executed, a menu window appears. At the top, a drop-down list of log timestamps is available, allowing selection of the time column that represents the sequence of collected stdf files. If no time columns are available, all nominal columns are listed, making it possible to select the one that best represents the test sequence. Next, die identifiers need to be specified, including device ID, X and Y coordinates, wafer, lot, and temperature. By default, these fields are pre-filled with prober information. Below this section, the Keep Insertions frame allows selection from 3 insertions: virgin, retest, and final. Virgin represents the first test on a given unit. Retest provides a summary of all retest results. Final merges the virgin test and the last retest for a given unit. Whenever a device is retested, the last retest replaces the virgin test result. Any combination of virgin, retest, or final can be selected. For this demonstration, all 3 will be chosen. After clicking OK, the function processes the data in a few seconds and returns a new table with the selected insertions, while the original table remains intact for further analysis. Information about each insertion type can be found in the first column of the new data table. Now, let's visualize these results using a wafer map. With the insertion column present, the wafer map now includes final, retest, and virgin test results in separate columns, while the rows contain lot and wafer information. To make the data more meaningful, the wafer map can be colored based on specific parameters, such as test results or pass-fail conditions. This allows for a clear identification of which devices were retested and how they performed compared to their original test. In some cases, a dataset may contain packaged devices with no prober information, meaning there are no correct X and Y coordinates available. Again, this can be demonstrated using the generated basic wafer map, where all coordinates reflect missing values. Let's start the retest algorithm function again from the drop-down menu. When the Utilize Test column checkbox is selected, a list of suggested test names is generated using advanced pattern search algorithms, providing columns that most likely contain X and Y coordinates, wafer lot, and temperature data. These suggested columns help ensure accurate identification of key parameters, even when standard prober data is unavailable. After selecting the necessary columns and insertions, clicking OK generates a new table with the extension Retest Algorithm applied. Switching to wafer maps allows for visualization of these results once again. This process provides a structured way to track the progression of test data, even when coordinate information is missing. The retest algorithm is a powerful tool for distinguishing between first-time tested and retested units. It works for both wafer-level and packaged devices, even when prober data is unavailable. The function allows for selection and analysis of different test insertions, and with visualization tools like wafer maps, valuable insights into retest trends can be gained. That concludes this tutorial on the retest algorithm function in YieldOptiX. Thanks for watching.